All right, I would say let's slowly get started. Thanks everybody for joining. I would suggest we start with a quick rounds of introductions. First of all, I'm very excited to have Eric Kish with us here today. Eric is the CEO of Nanoramic. Nanoramic, in my eyes, one of the most innovative battery companies out of the US that work on special electrode technologies to reduce not only the environmental impact of batteries, but also improve the performance at the same time. Welcome, Eric. Thanks for joining.
Thank you for having me.
Then we have Mario with us, Mario Gehrlein. He's the co-CEO of E-Lyte, a German-based company that produces high-performance electrolyte formulations that are really tailored to the individual cell chemistries, as I understood, and thereby get the best out of each of these technologies. So really great to have you here with us, guys. Thanks a lot for joining. For all of you that don't know Sphere so much, just a quick overview. We are a technology service firm that provides services along the battery value chain, really from engineering, cell benchmarking to strategy and regulatory advice. But today it shouldn't be about our companies. That's why I switch over to the roundtable. And so we have a very pressing topic today to discuss, right? The PFAS regulations. Some of you may have heard about it already. For those of you who don't, Mario, maybe why don't you give a quick introduction what PFAS materials actually are and how they're used currently in batteries?
Yeah, I mean, thanks for the question. PFAS stands for pair and polyfluoroalkyl substances. And if you look at the documents which the European Union released in this regards, there are more than 10,000 different substances included in these PFAS regulations. So you have a number of chemicals which falls under PFAS. In the European document, there are already also some exemptions which are not, let's say, in the group of PFAS, but not looked at for these regulations. And PFAS are today used in the battery in different components because they have some special chemical properties. And some examples where they are used is, for example, in the electrolytes, but only in small percentage for some of them. Also, they are used in active material masses, for example, as binder, or as sealing materials, for example, in valves or gaskets, and also in the coating process.
Yeah, and I think this makes these materials pretty essential for batteries, right? And that's why I would like to open up the round also and make it a little bit interactive with a quick poll to understand really, have you checked what impact the new PFAS regulations will have on your company? So there's a little window popping up now. Please just give a quick feedback for us. If you have read about it, if you have fully understood it, and if you maybe know what impact it will have on your company. So a couple of answers are coming in already. Seems like it's a split between, yes, it will have a strong impact on my company, and not really sure what this is all about. So Eric, with that, it looks like people are either concerned about how it will affect their business or don't really know what's going on yet with these regulations. Maybe you could shine some more light about what the current discussions are and why the EU especially comes up with these new regulations.
So we were surprised as everybody else when the January proposal came up, and we actually found out about it almost by accident, in the sense that there is a Swedish paper out there. I didn't even know what PFAS means, to be honest with you. So until I read a paper from a Swedish university connecting directly batteries, meaning PVDF and PTFE, to the PFAS class of chemicals. And I had to do some reading about this to understand what they're talking about. And then, the whole PFAS seen unfolded with things in the US happening with huge litigations, and then this is kind of a spilling over Europe. But then I started to read the proposals from these 5 Nordic companies, Nordic countries, I'm sorry, and it says there that they, although they do identify PFAS use in lithium-ion battery industry, at this point they think there is no alternative. But as the way I understand this initiative is that it's not that they will give derogation forever for a specific industry. Essentially, the longest derogation for any PFAS across any industry will be 13.5 years. And so I guess anybody who uses PFAS today should be worried, at least in Europe. So, but then coming back, our technology happens to be PFAS free. Just happens to be. We never designed it to replace PFAS. Actually, the reasons why we had to replace PVDF as a binder in an electrode happened 12 years ago when NASA asked us to fly a battery to Venus and back, and had to withstand, plus 300 degrees Celsius, minus 110. And no electrode made with PVDF would have survived this journey. It would have melted probably at 220, 240 degrees Celsius. So this is where the core invention of Nanoramic happened around 10 years ago, and then eventually it became electrode manufacturing for supercapacitors, which also happened to be very similar to batteries. And we started to apply this about 4 years ago with great success. But people that talk to us don't talk to us or don't try to adopt our technology because of PFAS issues. This is sort of a nice benefit to have, and now it has a name. Before it didn't have a name. But the main reasons why the industry wants to adopt a technology is first to create a better product and eventually a cheaper product, which is our main value proposition. And if it can also be a drop-in in existing manufacturing lines, that's a huge advantage because you don't have to replace billions of dollars of investment. And then, of course, if you have benefits from an environmental standpoint, and in our case, it's not only PFAS-free, it's also MP-free, and it also reduces about 25% of the CO2 emissions. That's a nice-to-have part.
Absolutely. And Eric, maybe before we come into the solution part of things, like what is the timeline we're looking here at with these PFAS regulations? Like, is that something that is coming up in 20 years, or are we talking shorter timelines here? Because we all know regulatory organs usually take some time, but it seems like this is pretty on top of the EU's agenda.
I can only state what I'm reading, yeah? So from what I'm reading, they want to pass regulation in 2025, which is 2 years from now, and then they will allow in this period the requests for derogations or applications for derogations industry by industry. This is not a regulation related to the battery industry. Mm-hmm. This is across the board. And then if I understand well, if there is no derogation, you have 18 months to remove PFAS, and then you can have 2 types of derogation. One is, I think, 6 years, and the other one is 13.5 years. So that's it's around the corner.
Timeline. So that's kind of like a 3-4 year timeline here we're looking at, which most likely will impact the entire supply chain of batteries. And maybe Mario, a question to you.
Just to add maybe on this side, and especially because the last deadline to, let's say, put in the request for exception for your application, for example, or for your substance is by Q4 this year. So that's the deadline where you can pull in your, let's say, documents or your argumentation why you need an exception for your substance or for your application. And then, as Eric said, then the clock is ticking, and then you have between 18 months up to 13.5 years. This depends on their decision. But, and that's also important to know, there's still a chance to get also 100% exception for your substance. So that's also possible. It's not that all PFAS substances at the end will be forbidden. Also, at the moment, if you look at the EU documents, there are already some exceptions there. For example, for medical treatment, etc. So there are some exceptions out there, and maybe this list will be a little bit longer. And if you look at the REACH regulation, for example, and how they classify batteries, I mean, battery is seen as an article with no intended release of the, let's say, components. And that's an advantage of the application of the battery itself, let's say. And this in combination with the political importance of the battery in the European Green Deal, there is still some, let's say, open small, but there is still a small open door that there will be some exceptions. I don't want to say that PFAS is not relevant for the battery industry. It is, as Eric said, it's very critical at the moment, and there's a lot of substances which for sure will be banned, but there's still a small gap open.
Is there actually anything anything similar in the US happening, or are we only talking EU markets?
So I think what's happening in the US right now is more driven by litigation. So in the last 30 days, some major settlements happened. One is 3M, the biggest one, $10 billion. And it's only for, I think, firefighting foam. So it's only one category. But as a result of that, you already saw 3M announcing that they will exit any PFAS business by 2025.
Insane.
And that there are other litigations happening with the other major players in the market, which will probably end up in settlements, but these are very big settlements. And there is also an investor sentiment in these companies where they want them to exit the PFAS business. So 3M taking the lead right now, it's a very interesting thing. And one of the reasons why the battery industry might be at risk, it's not only because of regulation, but maybe because the product itself will stop being produced by the existing producers. Because I don't think the big companies will be able to separate the PFAS subject per industry. You know, and tell people, look, in some industries we want to supply, in some industries we don't. So that's a very different angle that is happening in the US, although you can see the EPA already reacting to this. They are looking at specifically banning certain PFAS products, but also extending potential liability to existing products. So it's not as fast as the European Union wants it, but again, it's mostly driven by litigation right now.
Interesting. So if the big major players exit this game, this will have a massive effect on the supply chain as well, right? Even if there is a little small gap for potentially still using PFAS materials, if this big supply is not there anymore, that's going to be critical.
Lukas, I want to add one more thing. I don't think the battery industry now consumes a lot of PFAS. I mean, at least in electrodes, you have maybe 2% of the total mass of an electrode. What people are concerned right now, from what I see, is the fact that the industry is growing so fast that they will lose control of these quantities. They are mentioning that the quantities in batteries will grow by an order of magnitude by 2030. So these quantities will not be insignificant anymore, therefore will be on radar of regulators, etc.
Interesting. So before we come to our next little poll, which I just started now about the access to PFAS alternatives, I just wanted to mention that you guys can, if you have any questions for the speakers, you can just put them in the chat, and I'll dedicate them then to the speakers. Mario, maybe coming to a next question, talking about alternatives to PFAS materials. What do you think from an electrolyte perspective is possible? When we look at the electrolyte, I still know from my time in the lab that LiPF6 plays an important role there, which is basically the majority of elements in there being fluoride. So can you talk a little bit about, from an electrolyte perspective, what the community is doing, and especially also what E-Lyte is, in which direction you guys are thinking?
Yeah, so I mean, and as Eric said, that's a coincidence for us that, for example, LiPF6 is not within the PFAS regulation. So from our perspective at the moment, if you look at our formulation recipe, at least 95% of our electrolytes are already PFAS free. Of course, there are some electrolytes, and if you're looking at very special applications, for example, lithium sulfur, there are some components and additives or also salts which are good and beneficial for the application at the end, naming, for example, LiTFSI, and they are under the PFAS. And there we're looking, of course, now to the decision which is coming out from the European Union, let's say latest in 2024. But of course, I mean, our mission at E-Lyte, as you mentioned also at the beginning, is to develop the perfect fit electrolyte solution for all applications and batteries. So we are already looking in our R&D to develop for all applications and all our customers PFAS-free electrolytes, and it's possible. Of course, if you have to replace a component in such a, let's say, complex system like the battery and also the electrolyte, it's not easy, and it takes some R&D know-how and also resources, but it's definitely possible, and we are optimistic. It's like Eric said at the beginning, for them with their technology, it's a coincidence. For us, it's the same. We have also the advantages already now. Most of our recipes are PFAS free, and it's possible to replace the other ones.
Great. So just to give you some feedback from the poll, over half, almost 60% of the participants don't have access to PFAS-free alternatives. And maybe Eric, you mentioned that binder and especially electrode components are may fall under the regulations. What, from your perspective, can be done in terms of alternatives, and where do you see the supply chain heading there?
So in our case, we don't position ourselves as a replacement for PVDF or PTFE. We just say we don't need it, okay? And the reason is we create the binding function in a very different way that doesn't require a polymer for it, or polymer binder with its mechanical, stable mechanical properties. What we do is we replace this with a 3-dimensional nanocarbon structure, and this carbon structure, it's by definition extremely electrically and thermally conductive. That's the nature of nanocarbons. But also we found a way through the manufacturing process to enable the mechanical and adhesive properties of what a PVDF would give you, okay? So, and again, this is not something that was invented yesterday. It's been started 12 years ago, became commercially available in 2014, and it's now in commercial applications in aerospace and defense and oil and gas for at least 8 years. Yeah, so it's not new. 4 years ago, we decided to transfer the same manufacturing process to lithium-ion batteries, which is slightly different materials, but immediately we could see major benefits in cost. So again, the people that work with us and invest in us, like General Motors, they didn't really know what PFAS is. What they wanted was cheaper, cheaper per unit of energy and better performance. In this case, much higher energy density, much higher, much longer lifetime, etc., etc. And if possible, with the same equipment you already have, which is, so we are a wet coating process. We use the same coating machines. The slurry making, it's almost identical. It's what it's called a drop-in solution. Now, if you don't use PVDF as a binder, you also eliminate the other thing that you need, which is called NMP, the NMP solvent, which, by the way, the EPA already declared it in December last year as toxic to humans. So I would assume that at some point it will become regulated. But these two things are not required anymore if you if you manufacture electrodes with the neocarbonics manufacturing process, which is what we developed.
Nice. Great stuff, Eric. Maybe a question for you, Mario. Do you see any, I mean, now we heard of a great alternative for PFAS-free electrodes, but do you see any impact on performance and cost when changing electrolyte formulations or maybe even other compounds of the battery here?
I mean, I think it very much depends at the end on the application and the cell chemistry you're looking at. I mean, as Eric mentioned at the beginning, for them, it was a coincidence that their very good technology, which was not developed to be PFAS free, but to increase the performance, they did it. So even without PFAS, we have already one example how to increase the performance of the battery. And I think, of course, it is possible if you have a great R&D team and putting a lot of resources in it, you can achieve these results. I mean, but also, as mentioned from my side already, if you have such a complex system like a battery or the cell, it's not that easy to just remove one component or one substance in the electrolyte and say, okay, replace it with something else and it will work, because everything is interacting with each other. And it's always finding a balance between all components. And when we develop a recipe for electrolyte, we always try to balance all components, which means not only additives, also the solvents and the solvent mixture and the salts. So removing one substance can definitely have an impact on the performance, but at the end, it could also increase the performance. So this question is really to answer, I think, so it could happen both ways.
Interesting. Do you at E-Lyte have a dedicated team now, or do you switch at least part of your R&D focus towards PFAS free?
Yeah, as said, the good thing is, as we already have 95% of our electrolyte recipes without PFAS, we only need to focus on this 5%. And of course, as we are a European manufacturer and we will be compliant with all the European regulations which are coming up, we are now looking very deeply into this topic. And as soon as there is the official green light or approval from European Union that PFAS will be regulated also for battery, also for electrolytes, and for all our components, we will focus very much to replace all of them.
Awesome. Eric, you mentioned earlier the supply chain in M3 pulling out of this. Do you see any other major changes there? And should people be worried to get their components in the future? Sorry, I think.
Give me a second, I was on mute. Look, it's just my humble opinion that the battery industry will just be affected as a consequence of large producers stopping making this stuff. I don't know how fast it will happen, but I don't think the battery industry is a big part of the PFAS, the PFAS ecosystem. And even if it grows by a factor of 10, it still won't be in quantity-wise as big as the other applications. But I think the industry will adapt pretty fast. I mean, of course, we could have a solution about this, but there are other researches that are happening right now to eliminate NMP, to eliminate PVDF, and we are innovative enough as an industry to overcome these things. eventually, I think this will force the industry to become even more innovative and create and leapfrog existing barriers, because everybody who developed batteries just assumed they need to use PVDF.
Yeah.
Okay. And now this push forward will make them look outside the box. I think there are a lot of options outside the box, and because the industry needs this stuff so much, they will come up with I think great solutions that will generate much better batteries, not only environmental free batteries, but much better batteries in terms of performance, in terms of cost, etc.
Awesome.
So I'm not necessarily worried. I'm just saying that the industry has to be aware and sort of plan for it or prepare for it.
Yeah, awesome. So maybe coming slowly to an end, maybe Mario, summarizing all that, having heard all that, what would you propose to battery manufacturers or anyone that is building batteries now? How should they act? Should they be reading the regulations? Should they file until Q4? Anything about the components they use, or what's next steps for people?
I think you already nailed it. I think very important is that the whole battery industry needs to address the concerns they have about these regulations and put in their, let's say, exception requests. Doesn't matter if it's an electrolyte manufacturer, additive manufacturer, or cell manufacturer. That's option one. But of course, we all need to, as Eric also mentioned, it will happen. The ban will arrive us, and maybe there will be some exception, but for sure not all of the components in battery. So we really need to focus all R&D capabilities and resources that we have to find alternatives. As you heard today, on Nanoramic side, they have a very great technology, which not only replaces PFAS, but also improves the performance and reduces cost at the same time, which is, I think, very significant impact. And on our side at E-Lyte, we have the same thing. We already have 95% of our electrolytes PFAS-free, and also the last 5%, we are very confident that we will get this done to produce PFAS-free electrolytes 100%. And that's possible, but it's only possible if you focus on R&D and if you have the capabilities and resources, especially to do in-house testing, which is very important.
Awesome. Thank you. Anything to add from you, Eric?
Maybe one thing that I didn't mention. So I mentioned the supply part of things, but I also noticed that there are companies and users of batteries that decided to eliminate PFAS out of all their products. The most notable one that I found was Apple. Apple actually has a statement since last year where they recognized the PFAS issue, and they say they are working with their supply chain to completely eliminate PFAS out of all their products. So you also see it on the other side of the supply chain spectrum, which is a notable fact. What I want to sort of stress is that, yes, this is an issue right now. I don't think it's an issue that will destroy the industry by any measure. I think there are a lot of people working on this, even if they didn't think about PFAS last year. Now they have an additional incentive, but the industry can do some research on their own and figure out what's available out there, because it's coming.
Yeah. Awesome. Thanks a lot, guys. Thanks a lot for taking the time. Thank you, audience, for joining in. If you have any further questions, I think you know how to reach us. It was a pleasure to have you all here. If you have one more second after the call, if you close the window, there pops up a little feedback section there. If you can just give us your feedback, that would be great to improve for next time. Thanks a lot, Eric. Thanks a lot, Mario.
Thank you.
Thanks for joining. Bye-bye.
Thank you. Take care.